Hello everyone, and welcome to today's video. Today we're going to be discussing the Pythagorean Theorem solver in Python. This is going to be a part of a 3-video series. In this first video, we're going to be discussing how to code this in Python. Then we're going to learn how to code this in JavaScript, and finally we're going to bring the two together, and we're going to note the differences between the two programs so that you can better understand the differences between Python and JavaScript in terms of the syntax and all that kind of stuff. So let's get started with the Pythagorean Theorem. So if you look on screen, you'll see an animation, or at least a picture, of a triangle that has a right angle inside of it, which is denoted by the square on the vertice, or at least half of a square. On the square, you'll see, on this triangle, you'll see that there's two sides of this triangle that connect with to make the square angle, or the right angle. And by the way, the right angle denotes a 90-degree angle. So across from this 90-degree angle, you'll see what's called the hypotenuse, which is the longer side that connects to both of the legs, which are the sides that are shown with these arrows here. So the legs are, according to Pythagorean, somehow resembled to the hypotenuse, right? So Pythagorean then found out that the sum of these of the legs squared. The sum of the square of the legs is equal to the hypotenuse, which means that if you take leg 1, which is denoted with the arrow here, and square it, and then you add leg 2 squared, then you're going to get the hypotenuse squared. So using this, you'll be able to solve many different equations or many different problems that you may receive that have to do with the right angle triangle. But just remember that this only works for a right angle. So let's learn how to code this and how to make a solver, which will allow you to do this automatically without doing the calculations by hand. So let's do it. Going back to Visual Studio Code, you can see that I have created a file called main.py. And in this file, we're going to be coding our solver. So you can name your file whatever you'd like to, but I named my main.py. So let's start. So first, create a function, which you can do by writing def or define or something like that. I don't remember what it's called. And then you write the name of the function, which is going to be Pythagorean Theorem solver, right? But I'm just going to write Theorem. I'm just going to write Theorem solver underscore solver, right? And then after this, you can write down your parameters, which are going to be denoted with these parentheses right here. And then you make a colon, and then you press enter. So now you have this here, right? And you may be wondering, what are these parentheses, and what do you mean by parameters? What does that even mean? So that pretty much just means whatever inputs are put into this function, so that you can run the code. So what are our inputs? Our goal is to find the hypotenuse, right? So we can find the hypotenuse using which inputs? Well, it's leg 1 and leg 2, right? So we can put leg 1 and leg 2. So when someone runs this function, they're going to have to input leg 1 and leg 2 so that the program can work with these values to give back the hypotenuse length. So what you can do is we can say leg 1 squared is going to be equal to leg 1 multiplied by leg 1. So for those of you that don't know, a number squared, or a value squared, it's just that number multiplied by itself. So that's why I have leg 1 squared is equal to leg 1 multiplied by leg 1. And then we can do the same thing for leg 2. I'm just going to copy and paste what I had here. Now leg 2, leg 2, leg 2, just like so. And now we can use these values to return the hypotenuse squared. Because remember, leg 1 squared plus leg 2 squared doesn't give you a hypotenuse right away. It gives you the square of the hypotenuse. So let's include that. So that means that the hypotenuse, I'm just going to write as a shortcut, HYP is equal to leg 1 squared plus leg 2 squared. Just like so. But remember, this is just a squared version, so we can write down squared, right? Just like so, we have our first few steps completed actually. So now using this, we can find the actual hypotenuse, and we can do that by taking the square root of the hypotenuse. And the way we can do this is by importing a library in Python known as NumPy. If you don't have this already, you can install this library. It's very useful and has a bunch of math-related tools for people to use. And as a whole, it's just very useful. So I recommend getting it. Yeah, so import numpy, and then we can say that the hypotenuse, which I'm just going to write as hyp this time, is equal to the square root. So numpy dot square root of whatever you want to put in here, which in this case we want to take the square root of the hypotenuse squared, right? Which kind of cancels out with the square, which is what the square root does for us in this situation. So using that, we can now return hypotenuse, or in this case we can just print the hypotenuse. Perfect. Now let's run this function. So theorem solver, just like so, and we're going to put values for leg 1 and leg 2, which we can put as 3 and 4. So let's run this code and see what we get. We got 5. Perfect. That's exactly what we were looking for. So now look back on this animation, you'll see that if we have leg 1, which is equal to 3, leg 2, which is equal to 4, if you take these two numbers and you square them, then you're going to get the value of 9 plus 16, which gives you 25. And what number multiplies by itself to get 25? Well, it's 5, which is perfect. So that means that if you have a right angle triangle with legs 3 and 4, with legs which have lengths 3 and 4, that means that the hypotenuse will have a side length of 5. Perfect. So that's all I have for today's video. I hope you enjoyed, and I hope you have a great day.